Good evening all. I'm Arun, Assistant Professor of Department of Electrical History of Technology. In the subject Microprocessor and Compiler, today let us see 1885 instruction formats. Instruction. It is a command given to the microprocessor to perform a given task and specify data. Each instruction has two parts. A task to be performed is known as operand code or opcode, and the second is the data to be operated upon known as operand. The operand can be used in many different ways. Example, 8-bit data or 16-bit data or internal register or memory location or 8-bit or 16-bit address. 8084 instructions can be classified based on the size they occupy in the memory or the function they perform. The figure shows the classification of the instruction. This is the classification of the instruction in 1985 based on the size and based on the function. Based on the size, it has been classified as 1-byte instruction, 2-byte instruction, and a 3-byte instruction. Based on the function, that can be classified as data transfer instructions, arithmetic instructions, logical instructions, branch type instructions, stack type instructions, input output instructions, mission control instructions. Let us see in detail. Based on the size, the instruction can be classified as follows. 1-byte instruction. These instructions are 1 byte in size and hence occupy one memory location in RAM. Examples are CMA, RLC, RRC, RAL, uh, and so on. These instructions do not require any operand to specify in the instructions. Instead, the operand is compiled in the instructions. So 1-byte instructions, uh, this is a task to be performed. Add the content of register B to the content to the accumulator. So the instruction used is add B. So similarly, the task is to uh, move the content to the accumulator. So the instruction used is move C comma V, and the binary of it C comma E is this, that is 0 1 0 0 1 1 1. And similarly, the XOR code of this is nothing but 4F. And now the 2-byte instruction. These instructions are 2 byte in size, means they occupy 2 memory in RAM. For example, such instructions are move C comma OE. So this is uh, the 2-byte instruction. The task where to perform load in the data byte in the accumulator. So the instruction uses nothing but move A and the data. And similarly, 3-byte instructions. These are 3-byte in size and hence occupy 3 locations in memory, that is in the RAM. Example of these instructions are call and jump, etc. I mean, these are the tasks to perform, that is nothing but transfer the memory sequence to memory location. So here, this opcode is used, this is operand of it, these are the binary, and this is the hexa code of this instruction. Instruction set classification. An instruction is a binary pattern designed inside a microprocessor to perform a specific function. The entire group of instructions called instruction set determines what functions the microprocessor can perform. These instructions are classified into the following 5 function categories. Number 1, data transfer operation, arithmetic operation, logical operation, function operation, and mission control operation. The data transfer group. For a data transfer instruction set. The data transfer instructions mean data between register or between memory and the register. So these are the instructions that can be used to move a data between the memory and the register. So MOV, that is nothing but it moves MOV, move immediately, and similarly LD is load accumulator directly from memory. HTA is store the accumulator directly in memory. These are the instructions that is used to transfer the data from memory and the register. Also, this is for 8-bit and similarly for the 16-bit that is expressed by the letter X. As the name of the data transfer instruction implies that it deals with a register pair that is nothing but 16-bit. So here, when this X implies that is nothing but it directly says that this is 16-bit Data for 16-bit, that is nothing but that is for a register pad, which is LXI, LDAX, LDAX. So here STA is nothing but for input, store accumulated directly in memory. Similarly, there is a 22 is for a 16-bit, or otherwise it's for a register pad. And next, arithmetic group or arithmetic instruction or add, subtraction, increment or decrement data in register or memory. So these are the instructions that is used to do the arithmetic functions, which is nothing but add, subtraction, increment, decrement in the register or memory. So for example, so ADD, that is add to accumulator, ADA, add immediate data to accumulator, ADC, add accumulator using carry flag. And similarly, NXA is nothing but increment the register pad by 1, and DCX is nothing but increment the register pad by 1. These are some of the example of instruction set that is used in the arithmetic operations. Next one is the logical group. These functions perform logical or Boolean operations on the data in the registers and memory and on condition flags. The logical and or and exclusive or instructions enable you to set specific bit in the accumulator on or off. ENU, ENU, ORA, OR, XRE, XRI. These are the some of the instructions that is used to perform the logical functions, that is nothing but add, or, and exclusive are. And similarly, to compare the data, you can also use that is nothing but CMP and CMI. Next, branch group or branching instructions alter normal sequential program flow, either unconditionally or conditionally. The condition unconditional branching instruction are as follows: just jump, call, and return. Similarly, the stack instructions, these instructions affect the stack or stack pointer. Push, pop, that is the exchanging top of the stack with HL, that is a register pair, or otherwise with exchanger, that is nothing but exchange HL. These are the instructions that is used to perform a stack um, which affects the data. Next, input-output instruction, that is in and out. It is used to initiate the input operation and initiate the output operation, which is nothing but out. Mission control instructions: VI, DI, HLT, and LOT. And VI is enable an interrupt system, and DI is disable interrupt system. HTL is all, and LOT is no operation. These are the some of the instructions that we have seen in 1884. These are the reference book that we have used. Thank you.